Thank you. Hi. I just listened to Ian Cooper talk, and thank you, Ian, because he introduced the concept of orchestration, long-running process, how to manage process in the distributed system. This is perfect for my talk. This morning, when I wake up, I heard this music in my mind. I love the AC/DC, and I think it's a long way to the failure if you go to the success. It's not the similar word, but probably is the same. Most of the time, when we create our workflow and we distribute and deploy our workflow, doesn't matter if it's a monolith or a distributed system, what we desire that happen is this one. We start our process, we create an order, asking to our sales service to create an order. Then we move to the next step, and we ask to warehouse to prepare the order for the shipment. But before the shipment, we have to ask to our payment service to change the credit card of the customer. And at the end of the process, finally, we can ship the order to our customer. And we are very happy. And this is the happy part in the railway pattern. But what happens if we start our process with a request to our sales service to create an order, but when we ask to the next service to prepare the order, we have a failure. Doesn't matter if a software failure, hardware failure, infrastructure failure. We have a failure. And because we are running our system without the fault tolerance and all the tricky that Ian Cooper said before, our process fails, and we have a system failure. And usually, when we have a system failure, this is the situation when us, as developer, as software architect, I have to find my failure with the bug in my software. I have a plethora of service distributed in many nodes in my Kubernetes infrastructure, and we are looking for all these possible bugs, and we examine all the concurrent system, all the components of our system. We fix the bugs, we deploy the new version, but before to deploy the new version, for sure, we run all possible tests, chaos engineering, feature fitness, TDD, and so on, because all of us practical all these beautiful things before go in deploy. But despite all these beautiful and fantastic tools and things and approach to the software development, failures occurs. And why? Why, if I develop my software so good, I have all the tests that are green, my fitness functions are okay, why I have a failure? We have a failure because of this. I know it was 1987 when Peter Deutsch and his team at Sun Microsystems announced to the world the fallacy of distributed systems. But when we starting to deploy for a distributed system, most of the time we consider our software as it has to run on a monolithic system. But when we deploy for a distributed system, we have to consider that the network is not reliable, that the bandwidth is not infinite, that the network is not so secure as our PC, isolated from the rest of the world. And also, if you for sure know all this fallacy, because I'm sure that you know this fallacy, as Neo said, knowing the path, walking the path is not the same. We know that there are these fallacies, but again, when we develop our solution, we are focused on the business process, how to resolve the business problem, how to solve the essential part of our solution, and we forget the accidental part. What happens if my system fails because the network is not available? What happens if the system fails because the bandwidth is not enough for my messages? And because the failures happen. It is not a question of if a failure happens, it's when the failure happens. Because your system, I tell you a truth, is not infallible. Your system fails. Failure is inevitable. And the real challenge is not create an infallible system. You cannot. You cannot. Not because you are not so good, but you cannot create a system that is infallible. The real challenge is create a system that in case of a failure, it can resume. It can restart, not restart from the beginning, but resume from the last beautiful step, the last good step, and move to the next one. So the real idea, the real base is that unfortunately, we ignore the failures. We always think positive. Oh, for sure, it's impossible that my system can fail. Until the system fails, and we spend the time on the hours or the night, like the guys before, looking for the failures in our system. And the real challenge is creating a system that is prepared, is designed for the moment in which the system occurs. Back to the AC/DC. Writing code is like writing music. You can write your code in your language, inside your framework, and so on. You don't know if you are writing a good code until a processor, a machine, virtual or physical or node, I don't know what you prefer, run your code, and finally you can see the outcome. Oh, okay, it's a good result, yes. And the same for Angus Young. He writes his song on a music sheet, but until the AC/DC play the music, we don't know if Railway to Heaven is good or Railway to Hell is good or not. Okay? We have to listen to the music. Oh, great music. Okay. At the same time, if your software runs on a single processor and this processor fails, your code fails and you have an outcome. If the Angus Young guitars is broken during a concert, it's a disaster. An unexpected blackout occurs during an AC/DC concert, it's a disaster. So, but if you have more than worker that run your code, if a worker fail, you can move on another worker and your code is still working. The same for the music. If the Angus Young guitar broken, it can change the guitar at the fly. Oh, on the fly, yeah, I can restart the music. Or imagine, like if an unexpected blackout occurs, the music stops, and when the current comes back, the music restarts exactly from the last note played from the AC/DC, without an interaction. The role of durable execution is exactly this one. Durable execution is like having a process that cannot fail. Okay. Your process can fail, but because durable execution is monitoring your application, your workflow, and because, as you can see in a few minutes, they save and storage each step of your workflow, it can resume the workflow exactly from the last good point and continue the workflow to the next step. It seems like, oh, there is an interaction. It's a unique workflow, unique process that runs. So come back to the start. How a durable execution works. You start your process, like the first one, you start creating the order, asking to sales service to prepare the order. At the end of each step, durable execution automatically save the state of your workflow in a durable storage, in an immutable durable storage. It saves the state of workflow and the value of all the variables of your workflow. When a failure occurs, durable execution can move the workflow on another process, resume the process from the last point, and move to the next step. It's important to understand that durable execution resume the process, not restart the process. Durable execution guarantees that the workflow will be deterministic. That means if I start the process with the same input, I have to obtain always the same output. If I start the process and the process implies to a change for customer credit card and the workflow stops because a system failure or a software failure, I cannot change double the credit card customer. So I start my process this time because I introduce durable execution in my workflow. Sales create the order, and I have a failure. Warehouse fails. This time is the process that fails. But durable execution, after the sales step, storage the state of the workflow in a durable storage, restore from the storage the state, recover the action that warehouse has to be, and then move to the payments. This time, what happens if I have another failure? Not a software failure. It's not my warehouse service, my payment service that fail, but it's an infrastructure failure. My service is okay. You can analyze your code, run your test. It's all okay. All tests are green, but you have a failure because network is not available, because bandwidth is not enough, and so on. Durable execution move the process with another worker. In a couple of minutes, I explain what is a worker. Move on another worker, restore the process, the workflow from the durable storage, move to the payments, and at the end of the day, move to the shipment. So, the role of durable execution. If we look at our workflow, it's split in 3 processes. It starts in process number 1, then because of failures of warehouse service, it continues in process number 2, and because of system failure, an infrastructure failure, it completed to run in a process number 3. So durable execution works as a join, as a chain, as a bridge between all these processes, and collect all these processes, and it seems that these 3 processes appears to her as a unique process. So physical representation of the process inside durable execution, if you look on a durable execution platform, you see the 3 separate processes, but from the point of view of a developer, you can consider just a unique process that starts with the first service, sales in our case, and end with the last service, shipment, because durable execution hides to us all the failures that occurs during our workflow and resume the process exactly from the last point when the workflow failed. So now we have to rewrite all our code base because we have to implement durable execution in our code. Because, but I have plethora of code, line of code, thousands of lines of code, and because I have so many workflows in my code base, I have to rewrite all my code base to implement durable execution. Fortunately for us, no. I use temporal, but I'm sure, because I see also, restate work in the same way. This is the simple script of the workflow that I presented before. And what is now, I have my code that orchestrates my activity, in my workflow, and it's just enough that I add this small decorator activity to inform the durable execution platform that now this is a list of activities that the workflow has to run to start and complete the process. Okay. This is the code. After you create your list of activity, that is the only things that you have to add to your code base just now, you have to create another small class, the workflow. Again, you have to create your workflow as a separate worker, and you have to add the decorator workflow. And workflow run to indicate to the platform that this is the start of your workflow. If I run my workflow, I have run the worker before. So I run the worker. The worker is the node, the simple node that runs my workflow. So when you run your code in production, you have to have at least two of these workers, because if one fails, like in the first example, the first line of my example, if the failure is due not for a software failure or for infrastructure failure, durable execution can discard the first worker and move the process on the second worker. So in a production environment, you have to have at least two workers. And then I run my client. What can produce? All the durable execution platform provide a UI, a dashboard, when we can check what happened in our workflow. And as you can see, I ran my workflow, create sales order. That took me about 10 seconds. Then I moved to the second service, and the third, charge credit card, and at the end, the last one, payment. And if I want to check what happened inside each of these activity, I can expand, and I can discover when it starts, when it ends, what happened, it fails, why it fails for a software failure, because infrastructure failure, because the service is not available, and so on. Because at the end of each step, durable execution platform save the state of my workflow and allow me to analyze what happened during the running of my workflow. But is there some time constraint when run a workflow using a durable execution platform? When I use, for example, this platform, I have a constraint. I have to end my workflow in 10 minutes, 1 day, 2 days, 6 days, 1 month. I don't know what you want. No. Durable execution guarantees that your workflow can run until the process reaches to the end of its path. It can move from one step to another, also in case of failure. Again, it doesn't mean that your system can fail. Your system can fail, but durable execution can resume your system. That means that, for example, in a software that had to manage a loan of 20 years long, you can focus on business problem and not about what happens if my workflow fails during this time. Because if your system fails because the warehouse fails, you can analyze the warehouse service, you can remove the bug in your software, you can deploy the new version of the service, and without a manual intervention, the workflow resume the process, this time use the new version of the service that you deployed, finally, in this time doesn't fail, and can move to the next payment, and so on. Because all the durable execution platforms support an hot reload of the service included in your workflow. That's very important, because you can write your own state management to save your state after each step of your process. It's not an a difficult task, easy to implement. But it's not easy to resume the process and run with the new version of the workflow of the services. Because you don't have to worry about save the state of my workflow, consider the time that you can save when you use a platform to manage durable execution. I repeat, you can write your code to save the state, but it means that you have write the code, test the code, running the test in case of failure, resume the process from the start when it fails, and so on. And you can use a DB, even if your application doesn't need a DB. I don't know if your application doesn't need a DB, but it happens. So, durable execution is a crash-proof, guarantees a crash-proof execution. Crash-proof, it's amazing. My training watch is waterproof. Doesn't mean it can avoid that I can fall in a swimming pool. I can fall in a swimming pool. My watch still working after I fallen in a swimming pool. I don't know for me, but my watch for sure. The same for durable execution. If your workflow fails, durable execution continues to work, continues to save the state, and when you repair your failure, your durable execution is ready to restart, to resume, and continue your workflow. And because durable execution in a software solution of the problem, of the fault tolerance, is agnostic of the hardware. It's not the first time that we can apply fault tolerance to our workflow. Traditionally, there are systems that provide fault tolerance using an hardware solution. Sometimes a very expensive hardware solution. I worked for a bank some years ago, many years ago, and they have free HP server with 3 different lines to communicate with the external service, but it was a bank. It's very expensive. And an hardware solution can just reduce the possibility of the time of your failure. If a failure occurs, you have to, like in the example that I just did, move your software to another machine. So you have to shut down the first server, turn on the second one, move the code, analyze the code, run the code. For sure, you have ready because all the machines are equals, but you have to manually move from one machine to another one. It's not an automatic process like the durable execution. Durable execution is a software-based solution, and because I said support hot reloaded of your services, even if your service fails and you redeploy a new version of your service, durable execution, reload the new version of your service and can run and move to the next with the new version. Bingo. Tomorrow morning, because we have a hammer in our bag, all the problem will be nails. So durable execution everywhere. I just say that durable execution is just the last tools that we can use to ensure fault tolerance to our application. To be honest, it's not last, but in the last year is the topic of, oh, okay, durable execution in our whole solution. Even sourcing, that is a framework, a pattern that we talk a lot in this day, also share the same philosophy of durable execution. Both of these patterns save the state in immutable storage. The immutable storage is the key. If you want to guarantee reliability of your system, the storage, when you save your states, has to be immutable. But the concept behind event sourcing and durable execution is different. Durable execution is a mechanism to save the state of the workflow, the whole workflow, state and data of your variable. Event sourcing, as a definition, is a pattern when you save the state of your your system changement as events. It's different. You save event, you save a state. The goal for durable execution is guarantees the resume of the workflow in case of failure, but just in case of failure. Event sourcing aims to capture every change in your aggregate, and so in your state, and you can reply all the events because you need a new projection, not because you have a fail in your system. You have the history of your system, you can reply all the events and create a new projection. Or you lost your real model, you can reply all the events to recreate your model, but not because you have a failure. The goal is different. Also the persistent unit, because the persistent unit of the event sourcing is the event. To be precise, the domain event. The integration event is not mandatory for the integration event. You can save also integration event, but in another store, at least for me. The persistent unit of a workflow is the whole state of your workflow for the durable execution. For sure, both of these patterns are mostly used for distributed system. But I repeat, the first one is for in case of failures, the second one to rebuild the state of my aggregate, to apply a new changement of my state, or because I need a new projection. So the difference between event sourcing and durable execution are conceptual difference. The first one is about storing system changement. And because I save all the events that occurs in my system, and because the events are facts that happen in my system, I can consider the event sourcing like the source of truth of my system. If I need to create a new projection, if I need to verify, to checking for something, if I can apply a command, I use my events to rebuild my aggregate to apply a new command. So the focus on audit, replayability of my message, of my events, the consistency. Durable execution is about safe workflow and tracking the execution of my workflow. Because in case of failure, I repeat, I can use durable execution as my friend to resume the process. In common, they have the fact they use a state persistence. I repeat, just if you use a state persistence, you can deploy you can use this for restore your system. Because this, we can consider both of these tools, of this pattern, like our support for reliability. And I heard someone use, oh, I can use Postgres, MongoDB, or something similar as event sourcing. Yes, you can, but you haven't the immutability of your data. You can change the data. You can lose the data. You haven't the support for optimistic concurrency. You can have all the tools that an event sourcing can offer to you by design. So, again, they use in distributed system. And both of them provide dashboard to analyze what happened. But again, the dashboard for a durable execution is for analyze what happened in case my workflow fails, or just to analyze my workflow. If I look at event store, the store is different. In an event store, I have the store that what happened in my order. I create an order, I prepare an order, I close an order, and I can analyze the data inside each event, but it's about the data. It's about the state of my aggregate in that moment, not about what happened in case of failure. I don't know what happened in case of failure. Can I create a solution to guarantee the resilience of my long-running process using event store, event sourcing? Yes, you can, but you have to write the code manually. You have to write and test all the code. So, may I create a saga, Ian, before talking about saga, using just event sourcing? Yes, you can. You can orchestrate your saga, save the state of your saga in event sourcing, and when failures occurs, you have to write the code to restore the system, restore all your aggregate, your saga, and resume the saga from the point where it fails. Durable execution does it for you. So if your need is just reply the system state from the history, use event sourcing. If your state is guaranteed the observability and orchestration, a multi-step workflow, well, probably the most appropriate tools is durable execution. If you want to implement an audit of your system, a trace of what happened in your system, event sourcing is the tools. So, again, if you have to manage retry, timeout, waiting, and so on, durable execution is the tool. May I use event sourcing and durable execution both together? Yes, you can. If you want to combine both of them, you obtain a system that can resist to the failures and in which each component, each activity, each task of your workflow has an audit of what happened inside each system. You have the top of the gamma. Back to the distributed system fails. Why we have to use durable execution to fight the distributed fallacy? Because if we have a failure because our network is not available, durable execution ensures that we can resume the workflow when the network is available again, when the electricity comes back and the AC/DC can restart, resume the music of I wait to hell until the finish. When the latency of our system is too high and we don't receive the response that we expected in time, the durable execution apply all the patterns that necessary in this case, circuit breaker, retries, exponential retry, and so on, and they can retry and correct the latency different from 0. And when topology change because you discover that your system, your piece of code has a failure and has a bug, and you repair the bug and you redeploy the new version of your system, and topology of your workflow change, the durable execution move the task on the process on another worker and continue to work until the end. It seems that because durable execution is the topic of the last 3 years, it's a new argument, a new topic, but as frequently happens in our world, it's kind of, we reinvented the wheel. And Azure, since 2014, introduce Azure Durable Task on its cloud platform Azure. And the Azure Durable Function are based on this pattern. But they work only if you use Azure. Because the unit of storage, the DB storage for your durable task is a local storage, and it is on Microsoft Azure. AWS, of course, introduced the same pattern using the step function. But again, you can use step function. The task, the activity became Azure function for the first case, became Lambda function in the second case, but only if you use or AWS or AWS or Azure in the case. Temporal and restate are the platform that born in the last year, and you can use both of them in a cloud environment. They provide a cloud solution, and you cannot you can avoid too interesting how to save, how to implement all the infrastructure on your own self. But if you want, like my example, you can install the temporal on your machine. You can install temporal like a single node on a, or like a desktop, or like Docker, through a Docker Compose, or at least also with Kubernetes. But you have to manage the distribution of your storage, the maintain, duplication, and so on of your storage, and so on. If you use a cloud solution, you externalize the service, both for temporal or for restate. Again, in these days, I heard a lot talk about platform is the evil, platform is good, platform is the future, platform is a constraint. As always, when I have to choose between use a platform or implement by myself all the code, because we are all developers, because we are software architects, because we love the work that we do, the idea will be, oh, it's beautiful if I can write all my code from scratch. But what about the distillation pattern domain-driven design? Some subdomain are core, and I want to focus on this subdomain because is in this place that we have the value for my application. Other subdomains are generic, are support. Why I have to write all the subdomain? Probably sometimes it's better to use an external service that support my core domain. So I can focus just on core domain, not all the solution. So implementing all the subdomain have a cost. If I use a platform, it's not free for sure, but the cost at the end of the day is less than implementing all from myself. So use a platform, sometimes solve your problems. Just because my time is ending. We have to accept that the failure is not if happen, is when happen. Like if you write an event, it's not if my domain event change, it's when my domain event change. And because this, implementing durable execution pattern inside your code is a good solution to introduce fault tolerance in your solution. And as we saw in a little demo, it's not how I have to rewrite all my code. Both pattern, the both platform that I presented, temporal and restate, requires to add some decorator to your function, to your method, not all. So you can focus on the core domain when you deploy, when you develop your solution, and use external service like this one for generic subdomain. So platform has a cost, but platform solve many problems. Durable execution is one of these ones. This is all what I have to say about durable execution. You can find me at the Intre booth. Thank you to be here. Thank you to my friend Alessandro that written this book with me and suggested me a lot of things about this presentation. For sure, he has a lot after this presentation, but thank you. And this is all.